So we will be discussing complex sinusoids and frequency response of linear time invariant systems. Linear time invariant systems. Okay. Now see, we have seen in our previous lectures, for case of linear systems, linear time invariant systems, if you have a linear time invariant system, if you will give a shifted input, okay, if you will give a shifted input, it will result in a shifted output. Shifted output. If you will give a delayed input, it will result in a delayed output. So whatever type of input you will give, it will give a similar response. Okay. And we have also seen that the response of an linear time invariant system to a sinusoidal input, it leads to a characterization of the system behavior system behavior that is termed as frequency response of the system. Frequency response of the system. Okay. Now see, if you have a signal, okay, you have a signal which is a composite signal, So you have a signal input. It is made up of F1, F2, and F3. There are various frequency components in the input. Okay. Now, the response of this linear time invariant system, it will behave in a different way for frequency F1, and in a different way for frequency F2, and in a different way for frequency F3. So all these three frequencies, because they have different time period, they will be faced, or they will be taken differently. They will be taken differently. So accordingly, the output will be also developed differently. So for one type of input, because if you have one type of input, you will have one type of output. If you have another type of input, you have another type of output. Okay. So if we have various frequency components in our input, then your output of the linear time invariant system, it will give you a different output. Okay. It will behave in different way for different frequencies. So in general, we say the response of a linear time invariant system to a sinusoidal input, okay, sinusoidal input, leads to characterization of the system behavior. And system behavior will be different for different frequencies. So that is what is called as actually frequency response of the system. So this is nothing but it is frequency response of the system. Okay, so if you have a sinusoidal signal, which is having various frequency components inside, then you will have a frequency response, different characterization of that signal, which is known as frequency response. That is, the system will behave differently for one frequency and differently for another. If you will ask me that what could be a sinusoidal signal with various frequencies, I'll draw it like this. So maybe graphically, I will draw it like this. See, this is a sinusoidal frequency, but it has various frequency components. Okay, it has various frequency components. This is a sinusoidal frequency, but it does not have one frequency component. This is a fundamental frequency component whose time period is equal to t. That is true. But apart from that, you have very small, frequency components inside, which makes it distorted. So for a linear time invariant system, once a sinusoidal frequency with various frequencies is being given or fed to the system, it leads to the frequency response of the system. It leads to the frequency response of the system. And we know in general, when we talk about discrete time domain, we already have seen this, that output of a linear time invariant system, it is equal to summation of minus infinity to plus infinity h of k into x of n minus k. Okay, x of n minus k. Whereas whereas x of n is actually input to the input to linear time invariant system. Okay, we have seen it. हमने इसकी, if you know what is a convolution sum and convolution integral, these are the same equations that we have discussed there also. Okay, now see, if x of n is the input, okay, if x of n is the input, now let us assume that x of n is complex sinusoid. X of n is complex sinusoid. So x of n is input, but we are assuming that it is a complex sinusoid. It is input, but it is a complex sinusoid. It is equal to e raised to power j theta or j omega n. Okay, j omega n, e raised to power j omega n is a complex term. It is a complex term and it is a sinusoid also. If you know that cos theta is equal to e raised to power j something something divided by 2. We have already discussed those things. We have defined the cos theta and sin theta in terms of e raised to power j theta also. Okay. Anyway, so if we assume that input is complex and sinusoidal, then equation one will become y of n will be equal to summation of k equal to minus infinity to plus infinity. Then this is h of k, okay, into e raised to power, see this was e raised to power n somewhere here, okay, this was e raised to power n, e raised to power n, okay. So in convolution sum, the input gets modulated or it gets modified by n minus k, okay, n minus k. So you have to write down e raised to power j omega. अब n के बदले instead of n we will write down n minus k, not n, okay, n minus k. So this is what is this convolution sum for this complex sinusoidal input. Okay, we can rewrite this equation as e raised to power j omega n into summation of minus infinity to plus infinity h of k, just a second, h of k, okay, h of k, then this will be e raised to power minus j omega k, okay, omega k. Or in general, we can say it will be equal to h of e raised to power j omega into e raised to power j omega n. Okay, whereas h of e raised to power j omega it is equal to summation of minus infinity to plus infinity h of k e raised to power minus j pi k. Okay, so this is this term actually. So we are taking this term, we are substituting it, we are assuming that it is equal to e raised to power h times e raised to power j omega. Okay, h times e raised to power j omega. So let us call this equation 2. So this is equation 2 now. Okay, now we can say that hence the output of this linear time invariant system, okay, hence the output of system is also a complex sinusoid of the same frequency. Okay, so what I'm trying to say, if you have a delayed input, shifted input, your output will be shifted. If you have delayed input, your output will be delayed. And if your input is complex sinusoid, okay, if your input is complex and it is sinusoid with certain frequency f, then your output is also complex sinusoid with same frequency f, okay, with same frequency f. So this makes sense because we have already discussed these things, that whatever type of input you will give to linear time invariant systems, the same kind of output is being given. Okay, वैसा ही कुछ मिलता है. So I'm saying hence the output of the system is complex sinusoid of same frequency. Okay, which frequency? As the input frequency. As the input. But multiplied by the complex number. Okay, complex number. What is the complex number? H of e raised to power j omega. Now you see the output is actually here, y of n. So output is same, okay, as input. Output is same as input. What was our input? My input was e raised to power j pi n, j omega n, okay. The output is same, e raised to power j omega n, but multiplied by certain complex number. What is that complex number? That is equal to h of e raised to power j omega. H of e raised to power j omega. Okay. Complex number h of e raised to power j omega. So that is one thing. Now see the complex number, this complex number, this complex number, or I can say this complex scaling factor, scaling factor, which is actually h of e raised to power j omega, is not a function. It is not a function of n. Please note that you do not have n here. Okay, n is not present in this complex number, in this scaling factor. So this is not function of n. Okay, so your complex number or the scaling factor, it is not a function of n. It is not a function of n, but it is only the function of omega. But it is only function of omega. Yani it is only function of omega. What is omega? Omega is frequency. Okay, it is function of frequency. So this complex number will change for one frequency component and it will also change for another frequency component. Okay, so that is what makes it now. I was saying that the linear time invariant system, it will behave differently for one frequency component, and for different frequency component it will behave differently. The output will be different. Okay, that is being shown here. Now see, output is equal to e raised to power j h times e raised to power j omega into e raised to power j omega n. So this is a complex number here. This complex number, it is function of frequency. तो अलग अलग frequency के लिए this complex number will vary. Okay, it will vary for different frequency components because it is a function of frequency. Frequency is omega. Okay, it is not function of n but only frequency of function of frequency, that is omega. Okay, so please note that it is a very important conclusion here. Therefore, this complex number is also termed as frequency response. Okay, and is termed, क्योंकि ये frequency पे ही खाली depend करता है, it depends only on the frequency of the input. Therefore, it is also termed as frequency response of the, we are talking about discrete time signals. Okay, so it is discrete time system, frequency response of discrete time system. Okay. I will ask students if they have any question or not. Roll number 45, बेटा आपको समझ में आया ये?
नो सर उतना नहीं है एक्चुअली, थोड़ा ये हो गया था पिछले क्लास, थोड़ी मिस हो गई ना मुझे, मैं आइसोलेट हूँ अभी घर पे.
ओके, ऑल राइट. रोल नंबर 76, बेटा आपको समझ में आया?
जी सर.
कोई सवाल तो नहीं है?
नो सर.
व्हाट अबाउट 15?
यस सर.
बेटा कोई सवाल तो नहीं है?
No, sir.
27।
जी सर।
आपको बेटा सवाल तो नहीं है, समझ में
नो
आई
सर।
बात?
यस
ओके,
सर।
ठीक है। तो जिस बच्चे को थोड़ा कंफ्यूजन होगा, मैंने रिकॉर्डेड वीडियोस अपलोड किए हैं, आप उन सारी वीडियोस को देखें, आपको रहबरी मिल जाएगी वहां से, ठीक है। सो वी वर टॉकिंग दिस all in context with discrete time system, okay. Similarly, for continuous time domain, we can say that we know what is convolution integral. It is y of t equal to minus infinity to plus infinity h of tau, then x of t minus tau, okay, d tau. This is convolution integral. We know that, okay. So for this system, if this system would have been the system that I was discussing above, if this system is, for example, now continuous time domain system, then its output will be given as minus infinity to plus infinity h of tau e raised power j omega. अब यहाँ मैंने ओमेगा डिफरेंट यूज किया है, j omega, then t minus tau, then d tau, okay, d tau. Assuming input signal which is x of t, it is also a complex. It is equal to e raised power j omega t. Okay, we are assuming input signal x of t is equal to e raised power j omega t. So if your input signal is e raised power j omega t, so your system is linear time invariant system, and you have x of t equal to e raised power j omega t, then your output will be y of t, and y of t is shown above. Okay, so we have complex sinusoidal input. All right, now let's call this equation as equation 3. Okay, equation 3. This is equation 3, or uh, this is not equation 3. I'll mark a different equation. And this is equation 3 somewhere at the top. Okay, equation 3. Now see, equation 3 can be simplified as, we can rewrite this equation 3 as y of t can be written as e raised power j omega t integral of minus infinity to plus infinity h of tau e raised power minus j omega tau d tau. Okay, because this is a constant here. This is a constant. Why? Because it is e raised power j omega t. इसमें tau नहीं है. We don't have tau here. While as all this term, we are integrating it with respect to tau. Okay, so we have tau there. So first term is constant. That is why we have taken it out. It is constant. Okay. So similarly, we can write it as like this. We can write now the above equation as h times j omega e raised power j omega t. Okay, we can call this equation as equation 4. Equation 4. Whereas, what is h times j omega? H times j omega. I'll ask students what is h times j omega in this equation. I think roll number 27 will help me in telling what is h times j omega. 27.
e to power j omega t।
जी बताइए।
सर ये h टाइम्स e to power ये माइनस j omega t।
What is h times j omega equal to? E to power
माइनस j omega t।
minus j omega t. Are you sure? Okay. Maybe another student. Burhan, roll number 33. You will tell me. So he is saying that it is equal to,
Integration.
what is it
Integration
equal
minus
to?
infinity to infinity h of
Integration of
integration minus
minus in,
infinity to infinity
then
h of tau
h of tau
e raised power minus j omega t
e raised to power j omega tau or t?
t.
T?
Yes, sir.
Okay. T. All right. Then
D tau.
d tau. Okay. So I'll ask another student now. So let us ask another student. I think Ayman is here. Ayman बेटा 78 बताओ बेटा आप. हाँ बताओ. What is
Sir,
h times j omega? Integration of
integral of minus infinity to plus infinity
then
h of tau
h
e
of
raised
tau
to power minus e raised to
j
power minus j omega tau d tau.
theta. That is correct. Okay. First two students were incorrect. तो ये जो ये बच्चे हैं जिन्होंने ये कहा ये सही नहीं है. ओके ये सही नहीं है. I'll tell you why it is not correct. Uh, okay, all right. Now see, because they are incorrect because first of all you have tau here. तो किसी बच्चे ने t कहा था बुरहान ने तो ये सही नहीं है. ओके और पहले बच्चे ने शायद कुछ कहा था e raised power j omega t h of j omega is equal to e raised power j omega t वो भी सही नहीं था. ठीक है. So actually your h is this one. Your h of j omega is this term and it is equal to entire this term. Okay, it is equal to entire this term. और आपका जो बचा अब e raised power j omega t वो यहाँ पे भी है e raised power j omega t. Okay, so that is how h of j omega is equal to minus infinity to plus infinity h of tau e raised power minus j omega tau. तो आप attentive रहा करिए थोड़ा. This will help you. Anyway, so let us see, this is equation 5 now. Okay, equation 5. Now see here, if we see h of j omega, it is a function of only the frequency. It is function of frequency only. ठीक है, ये frequency का function है. Which frequency? Omega. Okay, which frequency? Omega. And it is not the function of time. It is not function of time. That is t. It is not the function of time. It is not function of time. Okay. Therefore, जैसे ऊपर हम कह रहे थे, it is and it is termed as frequency response. Frequency response of continuous time system. Continuous time system. ठीक है. So it is frequency response of continuous time system. जैसे हमने ऊपर कहा था frequency response. In the similar way, this is also frequency response. अब ये continuous time system का है. ठीक है, ये continuous time system का है. Now see, whereas h of j omega, it is also complex valued frequency response because it is a complex number. It is a complex number. It is a complex valued number क्योंकि इसमें e raised power minus j है कहीं पे. So I can write down here. See, the complex valued, is it fine? I'll ask students. कोई सवाल तो नहीं है? रोल नंबर 25 बेटा, आपको सवाल तो नहीं है कोई?
नो सर.
समझ में आया?
ये सर थोड़ा बहुत आया.
थोड़ा बहुत क्यों आया, पूरा क्यों नहीं आया? Where is the
सर
confusion?
बीच में क्लासेस थोड़ी मिस हो गई थी सर, उसी वजह से.
ठीक है, ओके. आप वीडियोस देखें, रिवाइज करें तो हो जाएगा. महविश रोल नंबर 65
Yes, sir.
बेटा, कोई सवाल तो नहीं है?
No, sir.
ओके. हसीब कयूम,
यस सर.
कोई सवाल तो नहीं है?
नो सर.
24
Yes, sir.
कोई सवाल तो नहीं है आपको बेटा?
No, sir.
व्हाट अबाउट बुशरा,
Yes, sir.
आपको बेटा सवाल तो नहीं है?
No, sir.
रोल नंबर 13
Yes, sir.
कोई सवाल तो नहीं है बेटा?
No, sir.
Okay, ठीक है. I'll continue. Now see the complex valued frequency response, which is h of j omega. It can be written in polar form. It can be written in polar form. Okay, we can write this in polar form also. So whatever complex number we have, we can write any complex number in polar form. Okay, so if you can recall that, if we have a complex number like this, c is a complex number and it is equal to a plus jb. A plus jb. J is the imaginary part and a is the real part of the complex number. Okay, so this is nothing but it is a complex number. You know that it is a complex number. हमने इसको क्लास में बहुत बार डिस्कस किया है. Why it is a complex number? Because it has a real part and it has an imaginary part also. Okay. Now see, in polar form, C can be written as C can be written in polar form as this. Okay. So C in polar form would be written as magnitude of C and e raised power j argument of C. What is argument? Argument is angle of C. Okay, angle of C. So it is basically magnitude and angle. In polar form, you write down it in the form of magnitude and angle. So I should have written it like this: C magnitude and angle of C. But since it is a complex number, so it will be angle will be at the top, e raised to power j of angle, e raised to power j of angle. Okay. So we can write this in the form of magnitude of C and e raised to power j argument of C. Okay. Whereas argument arg, argument of C is tan inverse of b by a. So how do we find argument of C? Argument of C is theta actually. Okay, it is theta. Theta means tan inverse of b by a. Tan inverse of b by a. If you have seen that complex, number triangle, that then you might have understood it. It's not that much difficult. It's very basic. Anyway, now see, argument of C is equal to, it is argument of C. Arg of C means argument of C. Okay, it is basically equal to theta, which is equal to arc tan. इसको लिखा जाता है arc tan b by a. Arc tan b by a. Okay, so what is arc tan? Arc tan is actually arc tangent. Okay, it is arc tangent of C. Arc tangent of C is nothing but it is tan inverse of b by a. ठीक है, वही मैंने शॉर्ट में ऊपर लिखा. Argument of C means tan inverse of b by a, which is nothing but theta. It is theta. Okay. Now see, since we have h of j omega, this is the number now, h of j omega. Okay. Hence, this is our number. So यहाँ तो हमारा number था c, लेकिन actually we have h of j omega. Hence, its polar form, we can write its polar form in this way. Its polar form will be, okay, what will be its polar form? H of j omega is the number. Its polar form will be magnitude of h of j omega. Okay, that is one thing. And e raised to power j argument of h of j omega. So that is the polar form of this number. This is how we can write the polar form of h of j omega. What is h of j omega? Complex valued frequency response of the system. We have seen it at the top. It is the frequency response of the system. Okay, frequency response of the system. Where in this equation, magnitude of h of j omega, magnitude of h of j omega, or this much term, what is it? It is now termed as magnitude response. ठीक है, इसको अब हमने दूसरा नाम दिया. Since it is magnitude of frequency response, so we say magnitude of hj omega, yani magnitude of frequency response is termed as magnitude response of the system. Okay, magnitude response of the system, magnitude response. Okay, so it is magnitude response of the system and is used to plot the amplitude spectrum. If you remember our previous lecture, we were discussing amplitude spectrum and phase spectrum, and is used to plot amplitude spectrum. Amplitude spectrum. Amplitude spectrum, okay? Phase spectrum, amplitude spectrum. Yeah, we can say amplitude spectra. Amplitude spectra is used to plot amplitude spectra. And in this equation, argument of h of j omega is termed the phase response. Okay, it is termed as phase response of the system. So we have now magnitude response and phase response. We have magnitude response and phase response of the system. Phase response of the system, and may be used to plot phase spectra. Okay, phase spectra. We know now amplitude spectrum and phase spectrum together they make line spectrum. So in this complex valued sinusoidal signal, h of j omega is the frequency response, and it consists, once we show or represent it in the polar form, it consists of two parts. One is magnitude response, another is phase response. Magnitude response is used to plot the amplitude spectra. Phase response is used to plot phase spectra. Okay, I'll stop here. If you have any question, you can ask me right now. Otherwise, we'll continue this lecture in our next